Assalamualaikum and hello everyone. Welcome back to physics lecture. For this second semester, we are starting our lecture with chapter 1, that is electrostatics. Let us discuss more about electrostatics. So for your information, electrostatics is related to electricity, and electricity is actually made up of electron. Electron is a charge, and charge can be moving and also non-moving, or we call it static. So for this chapter, electrostatics, we only focus on static charge, or charge that is at rest, or it can be moving but with very slow motion. So the case for moving charge is going to be learned from the later in the third chapter. In this chapter, we are having 4 subtopics. They are: the first subtopic is Coulomb's law, and the learning outcomes for Coulomb's law are first to state the Coulomb's law, to do the sketching for the electric force diagram, and to apply the Coulomb's law for a system of point charges. Okay class, for your information, electrostatics is also known as static electricity. So kat sini kita nak tengok satu simple demo how to explain static electricity. Okay, on my screen now I have 3 objects. I have a sweater, I have a balloon and a wall. So and these 3 objects are neutral because we can see here the negative and positive charge are balanced. So we can say they are neutral. But if I take this balloon and I rub it to the sweater, okay, you can see that the negative charge from the sweater is transferred to the balloon, right? So the balloon is made up of plastic and the sweater is made up of wool. So because of the material, that's why the negative charge from the sweater is transferred to the balloon. So now these balloons are negatively charged because it is having extra negative charge or extra electrons, and this sweater is positively charged because it has now extra proton. So next, what we do is we move this balloon to the wall. And you can see that when we move this balloon to the wall, the negative charges on the wall are moving to the side. So this is the phenomenon where you can see the negative charge will try to get away from the other side. So this is a phenomenon you can see that the negative charge on the wall are moving away from the negatively charged of the balloon. We can see that from the previous simulation that the unlike charges or different sign of charge will attract, and the like charges or similar sign of charges will repel. This concept is explaining Coulomb's law. This law is named after a physicist called Charles Coulomb. And Coulomb has done an experiment that confirmed the force between 2 static charges. Coulomb's law discusses the force between 2 static charges, and it states that the magnitude of this force between the 2 point charges is actually proportional to the product of charges, and it is inversely proportional to the distance between 2 charges, which means if you bring these 2 charges closer, the force will be bigger. And if we have a bigger magnitude of these 2 charges, you are going to get a bigger force. Mathematically, we can express the Coulomb's law with this equation, where K here is the Coulomb constant, and K can also be expressed as 1 over 4 pi epsilon naught. And the unit for force is Newton. Please bear in your mind that this force is also called as electrostatic force. If you would like to try the simulation by yourself, you can scan this QR code and have a go. As discussed earlier, the force can be attractive and repulsive. It depends on the sign of charges that act between each other. And the motion of these charges is actually telling us the direction of force, which finally will give us electric force diagram. This is how the electric force diagram looks like. It shows us the direction of forces or the motion of the charge. Let us talk about the symbol of the force. So we have one here, F12 and F21. This is charge number 1, this is charge number 2. F12 means the force acted on charge number 2 due to charge number 1. And F12 is the force acted on charge number 1 due to charge number 2. And for your information, both of these forces are having the same magnitude. For the system of charges, we have the first example, positive and positive charge will repel, and the instruction is to draw the direction on the electric force on Q1. So we focus on Q1. We only draw the direction from Q1 because the one that is acting is only at Q1. So positive will repel, meaning this Q1 tends to move to the left. It will try to get away from Q2. So this is the direction of force. So we label it as F12. Force acting on Q1, positive, negative will be attractive. So word. So we label it as F13. Positive, negative is also attractive. So direction is to the left. This is F12. Again, force acting on Q1. Negative, positive, attractive, F14. Negative, positive, attractive, so it's going to be diagonal, F13. Negative, repulsive, so it's going to be to the left. So this is F12. This is the electric force diagram for this case. To help us understand this chapter better, we can always compare this chapter with chapter 8 semester 1. I hope you can still remember. So chapter 8 we have Newton's law of gravitation with equation F equal to gmm over r squared. And for this chapter we have F equal to kq1 q2 over r squared. We can see that there is a similar pattern between these two equations. And what are the difference? We have Newton's law only have attractive force, but Coulomb's law have both attractive and repulsive. Newton's law is due to mass interaction, but for Coulomb's law is due to charge interaction. And Newton's law is a force in a long-range forces, and for Coulomb's law it is a short-range force.